Good morning and welcome to today's lesson. So today we're going to be working out of the textbook. There's a beautiful diagrams from pages 378 to 380 to look at some three-dimensional problems and some problems with some conjoined triangles. So you'll find those readings are actually still in here for us as Monday textbook readings. I'll just change that to textbook readings as these last two pages. So let's go ahead and we'll read those together. So, and I'll be, of course, popping into give you some different diagrams and stuff like that as we go. So the primary trigonometric ratios can be, can I zoom here? Can I zoom? Maybe Control plus? No, that won't work. It just makes the full screen document bigger. Okay, give me a second. Escape, and I'll pause. Okay, and we're back. So let's take a look. The primary trigonometric ratios. Okay, here, zoom in. Okay, there we go. The primary trigonometric ratios are applied in many areas of study, and many of you are studying some really cool applications of trigonometry right now, including architecture, engineering, and astronomy, even medicine and criminal detection. For example, have you seen a television show with forensic evidence is used to recreate the events of an accident or crime? So we want to know how this, how can they use a few tiny clues like blood stains to piece together what actually happened, and how can trigonometry be useful? So here's one example, and we have these angles of depression and angles of elevation are definitions we've talked about a few times. So here, if Kim lives over here and Yuri lives 20 degrees above Kim across the way. So these are two buildings. They face each other across a street that's 30 meters wide. And we want to know how high is Yuri and how high is Kim, given that Kim looks 40 degrees downwards to look at the bottom of the street and 20 degrees upwards to find Yuri's balcony. Okay, so first thing that we would do if we want to solve this question about Yuri is actually there are some. No, this would still be the easiest way, even after we have next unit. Okay, so the first way would be to say how tall is Kim's balcony, and we can use this triangle here to find the height of Kim's balcony. This is 30 meters and this is 40 degrees. So of course we can solve for that. And this is opposite and this is adjacent. So they're going to be using, oh, there it is, tangent. Tangent of 40 degrees is equal to this value divided by that value. And so then they multiply both sides by 30. Boom, boom, that comes up there. 30 times tan 40 is equal to about 25.17. So Kim lives 25 meters above the ground. So she's pretty high. And then how high is Yuri's balcony? Well, Kim is looking up at 20 degrees. So you might think, well, that's half. So maybe he's half that high. So that'd be another 12 and a half meters. And you would be wrong because that's not the way triangles quite work. So let's take a look. Over here, let's now look at this triangle. And it's 20 degrees, and this is 30 meters, so we want to have that. So it's, again, tangent. This divided by that is tan 20. That actually is 10.9. So not 12 and a half, but 12 and a half is pretty close. Okay, so this is about 11. So 25 plus 11, he is now 36 meters above the ground. Okay, so that's how, using the power of conjoined triangles, you see, we had to solve this triangle here and then solve that triangle there to find the total length. Okay? That's how you could use two trigonometric ratios together to solve that. All right. We can also work in 3 dimensions. Let's say we're across this river and the numbers, okay, so that's 61 degrees there. This is 75 meters along the shoreline, and that's 52 degrees, okay? What is happening here? This triangle here is a 90-degree triangle that's lying flat along the ground, or in this case, flat along the river. And the desired goal is to measure this vertical distance, okay? So this is a vertical triangle. So these are triangles in 3 dimensions. You want to imagine one of the triangles is like this, and one of the triangles is like that. And then we can solve for this common side where they touch. These are still conjoined triangles, but in this case, like angles don't add up or things like that. They're not related. They're in different dimensions. Okay, just the side is the same. So a theodolite is an instrument that's used by a surveyor to measure horizontal and vertical angles. Measurements are taken in order to find the height of a cliff on the other side of a river, okay, as shown. So if we walk along here, we can measure and use that angle to find the width of the river. Once we have the width of the river, we can use that to find the height of the cliff. Okay, so using a single letter to identify a side can create confusion. For example, side C could refer to the hypotenuse. Where? Use endpoints to distinguish line segments. Okay, all right, so we have X, and that's C there. So that's that line there, or X and Y. Sorry, that picture is not very, the glare is right on the diagram. It's not very good. I'm not going to do another picture though. We're this far into the video. So we want to find the height of the cliff. So we're going to use CXY, there, this triangle here. This is C, this is X, this is Y, to find the width of the river, CX. Okay, so that's CX. Cliff for C, I guess. Okay, and so here is CX, and that's 52 degrees, and this is 75 meters. So just a quick guess, I'm guessing somewhere around 85 meters. Oh, and it turns out to be 95 meters. So not a terrible guess, not great. Okay, how do they do that? Again, they're using tangent, all right? Opposite over adjacent. So they have their unknown up here, the opposite. It's that CX, that's what they're trying to find. It's over the adjacent, which is known, and the angle is known. So that's a number that your calculator can tell you what it is, and it's a little bit bigger than 1. So multiply both sides, and then you can solve for this distance. Cool. Now, that's shared by both triangles, this CX, okay? So you can use that to find the height of the cliff in the next page. And the next page is open on my computer right there. Okay, so now, oops, that's too far zoomed in, Mr. Jennings. Okay, so now focus on triangle CXF. Focus is a good word, isn't it? See, the page is a little rolly, so it's like in focus over here, but not in focus over here. All right, so there's CX, and they just found that with the other triangle, 96 meters, if you recall. This angle is also measured. That's the vertical angle that you have to look up at from one side of the river to see the top of the cliff. Okay. Again, it's using tangent to find the height of the cliff there. And so you have CF over 96. That's opposite over adjacent. Multiply both sides by 96 to get the cliff is 173.2 meters tall. So angles of elevation and depression. These are measured. I'll move my face down here. Above the horizontal is an angle of elevation, and below the horizontal is an angle of depression. So it's just definitions. The primary trigonometric ratios can be applied to solve two-dimensional and three-dimensional problems involving multiple triangles. It takes careful diagramming and careful naming of your sides so that you can avoid being confused by your triangles, and you just work through and you solve each one. And some complex problems involve working with more than one right triangle. You could have multiple triangles. And next unit we'll introduce non-right angled triangles, and they'll be even more complex again when we have multiple triangles going on there. All right, everyone, that is the brief lesson for today. I'll follow this up with a Delta Math walkthrough, which I'll post immediately. And I hope your math practice on this Frigid Friday is fruitful. Any questions, hit me up in the chat and by email. Bye for now, everyone.